Hello, welcome back. Today let's try to solve another Leetcode problem 259, 3 sum smaller. So we are given an array of n integer nums. So inside the nums we have n integers. It can be negative or positive integers. So we need to find the triplets index ijk. So the I should be more than or equal to 0, less than j, and less than k, and less than n. So basically we just need to find as many pairs as we like. So for this kind of a problem, it can be repeated like for the numbers, but for the index, it is always unique. We just need to find how many, unique pairs of the index, which some of them, the numbers, some of them is less than the target. This is a typical two pointers problem. Let me solve it in two pointers. So first of all, I need to sort the nums array. So nums.sort. After that, I just need to check how many pairs I have inside the nums. So this is similar to 3-sum. So I will just use the 3-sum template to solve this problem. But there's a little bit different for checking how many numbers of the result. So for the result, and n will be 0 because result is just a counter starting from 0, and n is the length of the nums. And for I in range n, let's prepare the two pointer. So the left pointer and the right pointer should be I plus 1 and n minus 1. So while L less than R. Because we need to check how many groups, so the L pointer should always be less than R pointer, so L cannot be equal to R pointer. So this is according to the definition of the problem, because we need to find the triplets. It means 3 indexes. It means I, J, and K. Now we are going to check. So what is the sum of them? So 3, I will name sum of the 3 numbers. It will be nums I plus nums L and plus nums R. This is much faster when you are using the method of sum in Python to calculate. Now we are going to check if this 3 is more than and equal to target, because we are calculating some triplets with the sum of them will be less than. So we will check two conditions. If it is more than, so it means the I pointer is too big. It will be shifted by 1 to the left side. We just need to check maybe there is a small number. Otherwise, we're gonna check how many of them. So how should we calculate? So we should calculate it using R minus L. Why? Let me give you an example. So for example, we have numbers, let me find a better example. Maybe we have numbers like minus 1 after sorting, minus 1, and 0, and 1, 1, 1. Now, for the first index, that is I. After that, we're going to prepare the left pointer and the right pointer. So for the left pointer, it is minus 1, it is here, and this is the right pointer. So basically, for the target, if I name a target, it is maybe minus 2. So these 3 numbers, minus 1, let me name a target. So the target should be 2. Let's name a 2. So minus 1 plus minus 1 and plus this 1 is minus 1. Minus 1 is less than 2. So up to here, it is okay. If it is okay, it means this number should always be okay, because if the biggest number, this one, is okay, it means if the number before it should always be okay, because this number is always smaller than the biggest number 1. So for this number, it is okay. This is okay. And how many numbers in total? We need to use the mathematics to check the index. So this index minus this index, yeah. So should be the result. Now let me check it. So if this one and this one, yeah, let's check how many of them. So 1, 2, 3, 4, 5. It means 1, 2, 3, 4, 5. These 5 numbers should always work. And the index, this one minus 1, this one, it is 5. So this is why we're going to use R minus L. Now, we need to update the L pointer, should be +1. After that, we just need to return the result. So the result is a counter. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. I think the only trick, maybe it is from here. Yeah, when this number is the first index I, and this is the L pointer, and this is the R pointer, you just need to use the result plus R minus L directly, because this is ON square time complexity. If you don't use this method, maybe cubic O cubic n cubic's time complexity, it will be exceeded for the time, it will be time exceeded. Yeah, because this n is like 3,500. It means it will be time limit exceeded if you use n cubic. Now let's just improve the speed a little bit, because according to the problem description of the problem and the numbers is also sorted, we can have a shortcut to check if we need to check other numbers or not. So the shortcut is if nums I is more than and equal to 1 minus 1 divided by 3 times the target. Yeah, what do I mean by this? I mean, if this nums I has already more than 1 divided 3 times the target, it means the other numbers must be more than this number, and it cannot meet the conditions to less than the target. So this is a shortcut. If it is like that, we will continue. We will not check it anymore. Yeah, I think we can use equal. Yeah, we still can use equal. Because if it is equal, if other numbers equal, it is still equal. Equal is not possible. It must be less than the target. Now let me run it to check if it works. Now let me submit it to check if we can speed up a little bit. Yeah, as you can see, it speed up to 90% of all Python 3 submissions. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like that. See you next time.